Alright, so problem 3 here, we're rolling a dice 60 times. So there's 6 faces that are right here, and here's the actual number of times each face came up, and then we're going to answer these questions A through G. Okay? So the first question is, how many times would you expect each face to show? Well, if I roll a dice and I roll it 60 times and there are 6 faces, I would expect them all to come up equally. So what I would expect to happen is I would expect each face to come up 10 times. So my expected would be 10 for each face. Okay. The next question is, what kind of test are we doing here? Well, we're trying to see how a distribution fits the expected distribution. So this is a chi-squared goodness of fit test. All right. And then C, it says we have to state our hypothesis. So the null hypothesis is the distribution of the faces of the dice is as expected. And then an alternative hypothesis obviously would be the distribution of the faces of the dice is not as expected. Another way we could say this also is that we could just say here the dice is fair. And then here we could say the dice is not fair. So that's another way of stating the null and the alternative. Okay. And then D, it asks us to do the conditions. So the data is counted, is in counts. Okay. Each roll of the dice is random and independent. And then if we look at our ECF condition, they must all be 5. Well, they're all 10. So all of our ECFs are all greater than 5. Okay. And then E, it says that how many degrees of freedom were there? Well, there are 6 different categories. So degrees of freedom equals 6 minus 1, which is 5. Okay. And then F, we got to find chi-squared. So remember, chi-squared chi-squared equals the sum of the observed minus the expected quantity squared over the expected. So I'm just going to do the first one and the last one. So for a 1, we actually had 11, but we expected 10. And then I'm going to just say, okay, I'm going to add up to my expectation for 6. So for 6, actually 6 came up, and I expect 10 there. So that's my showing the math piece. So then we got to put it in the calculator. So we're going to go to the calculator, and so we have 11, 7, 9, 15, 12, and 6. And then over here, each of these is 10. Okay, I'm just going to clear that up. All right, so those are your 2 lists, L1 and L2. Stat test, we're going to go to chi-squared goodness of fit test. So that is letter D. And my observed is in L1, my expected is in L2. I have 5 degrees of freedom, and I wanted to draw that. So that's what that winds up looking like. I'm going to copy that on our paper. So chi-squared is 5.6, and big P is 0.35. Okay, so that's what this looks like. Something like that. shade it in like about like that. Chi-squared here is 5.6 and big P equals 0.35. Okay, and then G, state our conclusion. So we reject at the 0.05 level. There is no evidence. We could just say there's no evidence that the dice is unfair. I'm just going to say there's no evidence that the distribution of the faces of the dice is different than expected.